I'm DYLAN Dryeyer. Join me on an adventure over 20,000 miles into outer space, where little bits of junk are causing very big problems. We're heading into orbit, exploring the massive network of man-made satellites that power global economies. But space is getting crowded. How will scientists clean up the heavens? We'll take a sneak peek at the most amazing solutions to rid the planet of space junk. On October 4th, 1957, the former Soviet Union successfully launched the first artificial satellite, named Sputnik 1, into orbit around the Earth. Now, after 60 years of space exploration, we're suddenly faced with a growing problem that seems more like something out of a science fiction novel, an orbiting junkyard of space debris that has the potential to change space exploration as we know it. This is Meteor Crater near Winslow, Arizona. It's considered the world's best preserved meteorite impact site. 50,000 years ago, a massive rock from space slammed into the ground with a force of 10 megatons, 10,000 times more powerful than the atomic blasts used in World War II. Meet Donald J. Kessler, retired head of orbital debris at NASA. His guide is Eduardo Gonzalez, a 16-year veteran of Meteor Crater and a man who shares Kessler's passion for the wonders of the universe.
So, Don, how was your ride up here?
Oh, it was wonderful. It was like landing on the moon.
But we're on Earth. Can you believe it?
At Meteor Crater, these two men always find common ground. For Don, this place brings some of the science of orbital debris to life in a big way. Nearly 1 mile across, 2.5 miles wide, and 550 feet deep. Meteor Crater is the astounding outcome of a nickel and iron meteorite hitting Earth with the force of a hydrogen bomb. It killed everything for 20 miles in all directions. And all of this happened in just 10 seconds. The meteor was most likely the result of a massive collision near the Earth. One of the larger pieces became caught in the Earth's gravity and rocketed towards the surface at speeds over 100,000 miles per hour. It's a sobering reminder of the incredible collisions that occur throughout the universe, from meteor impacts like this one to the collision of entire galaxies. Throughout time, space collisions have occurred as part of the natural process of the universe. Scientists believe that billions of years from now, our own Milky Way galaxy and its closest neighbor, the Andromeda Spiral Galaxy, could collide and merge to create a new, giant elliptical galaxy, spewing stars along the way. This computer simulation from the University of Illinois gives us some idea of what that collision may look like over the course of billions of years. Space collisions led Donald Kessler to ask a very important question. If collisions occur so frequently in nature, what's to prevent all of the man-made objects in space from eventually hitting each other? At first, Kessler's question was thought to be ridiculous. Until recently, many scientists have embraced the big sky theory. The big sky theory holds that space is so massive, you could launch anything into orbit and it wouldn't collide with anything else. But it turns out that space is smaller than we thought. Low Earth Orbit, or LEO as it's called, is home to the International Space Station, the Hubble telescope, and most of our satellites. In middle Earth orbit, or MEO, we find GPS and weather satellites. Geosynchronous orbit, or GEO, the orbit farthest away from the Earth, is crowded with communication satellites. With so many objects careening through the same altitudes, it's not hard to imagine that some will eventually collide. Donald Kessler predicted that random collisions between man-made objects would create smaller debris that would become increasingly hazardous to spacecraft. The resulting chain reaction would create exponentially expanding clouds of debris. His prediction became known as the Kessler syndrome, and it's proven to be correct. Is it possible that we're now at the tipping point of this cascading, uncontrollable event? And are the satellites that make our modern world possible about to be destroyed? Space is getting crowded. There are currently over 100,000 objects orbiting our planet, and that number is growing every year. From the discovery of space exploration to the conveniences of satellite communication, humans have developed a profound connection to space. But what would happen if it were all to suddenly go away? Launched in 1993, Cosmos 2251 provides communications for Russian military and intelligence forces from low Earth orbit. Satellites like this are part of what's called a constellation, a grouping of satellites spread out in a set of orbital rings, providing an uninterrupted stream of communications. These and thousands of other satellites orbit Earth 16 times per day. The gravitational pull from nearby Earth is so strong, every satellite has to travel at hypervelocity speeds, upwards of 17,000 miles per hour. The pull of gravity balanced against the satellite's velocity creates this curved orbital path. Satellites and their round-the-clock services are a fact of modern life. LEO, or lower Earth orbit, is ideal for communication satellites like Iridium-33, which provides voice and data coverage for cellular telephones. But with satellites like Cosmos and Iridium constantly crossing each other's paths in LEO, they often experience what satellite operators refer to as close approaches, two satellites passing within just a few short miles of one another. Amazingly, that can happen around 1,500 times a day. Space has indeed become a busy place. Just 50 years ago, the boundaries seemed limitless.
From a ground station nestled in the mountains at Andover, Maine, a signal is sent to a speeding satellite, an historic feat that could reshape man's future. That satellite, of course, is the Telstar. 170 pounds of messages and computer data, all can be handled by the orbiting device.
Ironically, this technological wonder died 1 year later, becoming what is known as a zombie satellite. But Telstar nonetheless began the revolution in communications that now features a fleet of satellites in the region we know as GEO. They facilitate most of the world's television, military, and internet communications. Because its orbit mirrors Earth's rotation, a satellite will appear to hover over a point on the Earth's surface. The result, 24/7 continuous coverage from air to sea to land. Satellites may drift due to gravitational pull from both the sun and the moon, slowly changing their orbits. Signals are sent to these drifting satellites, commanding them to adjust their orbits by firing up the onboard thrusters. But sometimes, wandering satellites cannot be recorrected and must be destroyed. This reality led to the largest debris cloud on record. In early 2007, an anti-satellite missile test took place in LEO. Its target, a dead weather satellite that was veering off course. In less than 24 hours, the debris encircled the Earth, hovering at the original impact altitude of over 500 miles. High enough so that the pieces won't come down, but low enough so that they have the potential to affect almost all other objects in low Earth orbit, including the International Space Station. Of the thousands of objects launched into space over the last 50 years, only about 1,000 are operational. The rest are simply floating, lifeless above the planet. Every single one of these non-operational spacecraft is a potential source of debris. In fact, most spacecraft that are launched into orbit actually leave a trail of debris in the process. Upper stage rocket bodies weighing several tons make up a good portion of the junk in space. The rest are miscellaneous fragments, exploded rockets, leftover fuel, and the list goes on. But even with this incredible amount of debris, few people were taking the notion of space junk seriously until the morning of February 10, 2009. Earlier that day, a report was issued predicting that Iridium-33 would encounter a close approach of just 1,900 feet with another spacecraft, Cosmos 2251. At 4:56 p.m., Iridium-33 went silent. Now, more than 100,000 pieces from this collision cloud low Earth orbit. The Iridium-Cosmos collision was very much a game changer, and people began to consider, what do we need to do to keep this from happening again? These computer visualizations show a fragment no bigger than a BB blasting through an aluminum plate. Even the smallest of impacts scatter debris, delivering widespread damage. Orbital debris traveling at these speeds poses a very real threat. Because of this, the International Space Station features extra shielding, as shown in red, over the areas most likely to be hit. To further protect the ISS, its orbit is monitored on all sides to help keep it out of harm's way. That's the job of the U.S. Space Surveillance Network, where they detect and catalog man-made objects. Utilizing a vast array of radars and sensors, we're able to track thousands of pieces of space junk larger than a softball. Some of them, like rocket boosters, are the size of a school bus. But what's far more troubling is all the debris that can't be tracked. Debris the size of marbles, like waste from rocket propellant and fragments from collisions, are capable of inflicting lethal damage. Over time, collisions will create more debris and, in turn, even more collisions. Gradually, the debris will shrink in size and speeds would slow. Finally, the Earth would be surrounded by stable, Saturn-like rings. So where do we go from here? Forces of nature and natural collisions will continue to shape our universe. But man-made collisions? Perhaps those we can do something about.
The good news is that people have begun to come up with new ideas to bring back the pristine environment that we would like space to be.
How do we catch up to and capture debris tumbling through low Earth orbit at thousands of miles an hour? And then, how do we slow it down so that it falls out of orbit and burns up in the atmosphere? One fascinating concept involves the use of a type of space tether, which would create a drag on the spacecraft through interactions between the tether and the Earth's magnetic field. This increased drag would lower the spacecraft out of orbit until it re-enters the atmosphere and burns up. We may also be able to capture the debris with a net. Japan's space agency has been working with a fishing net manufacturer to look at creating a space fishing net, which could be powered using the Earth's magnetosphere. Imagine that. A centuries-old fishing tool might just become a brand new tool for cleaning up space. Lasers could one day sweep space, striking smaller objects, slowing them down, and causing them to tumble into the atmosphere. Solar sails could someday be a part of the satellites we launch, helping them to deorbit once their work in space is done. What if one day objects in space were located and captured by a garbage vehicle? The vehicle could then dock at a recycling facility, a place where space debris could be stored and recycled to create new parts. Perhaps this space-based recycling will someday become a reality, launching a new, greener era of space exploration.
For as long as humans have walked the planet, we've looked up to the heavens to help us define our role in the universe. The celestial bodies above us and the constellations they formed have forever shaped our notions of time and place. Today, we are still called to the stars. Tomorrow, we may reach them. I hope you enjoyed our journey through space. Until we meet again, safe travels.